Now, hello everyone. Good day or night, depending on where you are in the world. We are going today to look into something that is not directly part of the CockroachDB project like we did in the weeks before. We are going to refresh an article an analysis really, that was published 2 years ago, initially corrected, actually 3 years ago, correct 2 years ago, and in fact it's a twofold. One is that I actually forgot most of this stuff, and it was pertaining to Go 1.13, and so it's probably outdated by now, and we will want to see if there are new results. Another aspect is that the technology that was used here is D3, which is a visualization framework for JavaScript, and I have some project where I would probably like to use D3, but also forgot everything I wrote back then, and so I'm going to reuse. I'm going to use this rerun of these experiments as an opportunity to relearn a little bit of D3 to get back into it, so to speak. So we are going to take this URL and then use it as a reminder at the bottom of the terminal here for context of what we are doing today. So how does this work again? I never remember how someone sets the Tmax. Let's copy paste this. And then we can continue. Poof. And now we have our URL here. It's kind of cutting a little bit the numbers I was having on the side, but it's okay. We'll pretend it's okay. Cool. All right, so we are going to go through this by starting on this repository that was here. We had a couple of Python scripts and some D3 visualization, and so we are going to refresh this code really. Let's change directories. So I have some issue, which is that I am currently running tests multiple machines, and I don't need that anymore. Let's exit all those sessions which are not needed anymore. My gosh, I should have prepared better, huh? Anyway, so we're back. I will also add my key display thing. And now we can exit this. Alright, so we have a README file, and it says, well, you can run the nm tool on a binary file, then rewrite C++ symbols, and then produce some file. Alright, let's do this. Do we have a test program in Go? Well, we have a cockroach binary, as usual. Right? Alright, so let's do this. So go tool nm minus size. Ooh, lots of data. Are still C++ symbols in there? Yeah, seems like it. Alright, so if we filter them, that will demangle the symbols, like we see those methods here are being demangled. And so here is results. What does the README file say next? Tab to pydict. So that's where we probably need to do some research. Tab to pydict. So there is a regular expression, which is a little bit complicated, but that's okay. Then there is some regular expression that is trying to do its best to identify the names of C++ methods. Same here. Then something about namespaces. All right. Then a Go expression here. So the Go one is the one maybe we will need to update. It will kind of depend on what we will see inside this file. So maybe that's what we actually need, is to study this a little closer. Like we have plenty of things, including structs like this one that is spanning multiple places, and then we have also equality dots and then brackets. So these brackets is something that's kind of new. So we will probably need to run this program, see where it fails. I hope it will tell us that it cannot parse certain things, and then we will revisit this source code. Tab to dict. All right. And it wants an argument. And then it complains. All right, so now we're talking. All right, so it tells us that some of these symbols doesn't know their syntax. That's okay. So what it doesn't understand is the fact that there is a double dot here. So that's okay. That's a new thing in Go 1.14. If I'm not mistaken, these are temporary file local variables. So it's okay. We need just to process those here. So Go path parts. So we have here something without parentheses multiple times, or something within parentheses multiple times, followed by a single dot. Yeah, well, that doesn't seem to work. That's the path. Well, that is a good reason. That's a good occasion to analyze this file. So we are going to look at how this overall program is working. So we are reading the file one line by line, and then it will match with the entries RE, which is like this. This means some digit or letter multiple times. Oh, that's like the address. Then a single number, then a space, then another space, something, and then something. So actually we want 4 columns, X address, number. Okay, so is that format still valid? Yes. So this is actually the hex address. The number is going to be the size, the type of symbol, and then the name of the symbol. So that's what we have here. All right. So that's okay. Then that is going to be the type number 3. Yeah, third column. That's the size, and that is a name. And then here we have a couple of different cases that we are going to ignore. Structure vtables, C++ static analyzers, C++ type metadata, Go generated type equality and hash function. Do we have those still? Yes. Yes. So all those type ... equal we are going to ignore. That's fine. Then we are going to match the C++ symbols. And C++ is a guard variable for or, then a type with some colons and some template part, which is this one with template parameters. Then we have a namespace and then something. So like all this C++ is identified by the presence probably of double colons or something else. So I don't exactly know. We'll see. But it's not C++ here. Like the program is telling us that it cannot recognize here. So let's see where it says. So it says parts is none. So it will do Go symbol. And these are Go symbols. And they're identified by path followed by dot dot followed by temporary variable. So Go path parts. So that's a Go sim re. Okay, so we have go.itab.something. Then otherwise, optionally, go itab dot star optionally followed by go path parts 0 more time followed by go last part. Okay, so what are go path parts? Go path parts are something that doesn't contain parentheses or something within parentheses where there are no parentheses within the parentheses 0 more times, followed by a dot, followed by or a struct, or a function, or a glob dot dot, or a go byte something, or a path. Oh, here we go. And then the go last part is going to be something called init done with a dot or with a middle dot, or something that will be a combination of first a name or something in parentheses, optionally followed by minus fm, or a struct followed by a comma and something else. All right, so that's because we have a interface wrapper. So there is some things that I'm missing. Is indeed the syntax for the double dot. That's new. So fun dot. So that's the one we are looking for. A dollar optionally followed by a word or a minus sign or a percentage followed by a dot. Interesting. And then a path. Okay, so I think it just means that the name of the symbol can start with a dot. So that's going to be 1 dot extra and see what it says. All right, that's much better. All right, so now we have here one symbol, so go.itab.star package name with a method inside following by something followed by here. Okay, so go.itab.star. Where's the go.itab? dot star followed by, if we ignore the stars, and we will have a path with a comma and then an interface. And the last part will be a comma. Where's the comma? Is here. Where was a comma? Where did we find a comma again? There was a part with a comma around here. So again, oh, here is the comma. All right, so the comma followed by interface something something. And that didn't work because the interface wants to encounter no brackets, no braces within the interface. That's what it gets confused. So this regular expression is meant to match this interface something with something in between the braces that doesn't contain additional braces. But we see here one additional pair of braces. That's what it got confused by. And that's where we need to have one level more of indirections. So what we want is here something like either some braces, something that is not brace, or a brace followed by something that is not a brace followed by a closing brace. Closing here. Let's see now what this thinks. I want this to be a 0 or more. Regular expressions are fantastic. All right, so that seemed to complete properly. So what does the README file say about this? All right. Then we're going to simplify to data.js. So what does simplify say? It doesn't seem to be. Simplify. Seems to be fine. And then we can start the HTTP server. And then we can load it. I think. And which file do I need to load? Treemap v3. All right, so we seem to have quite a big thing here. So let's continue here. ZSTD, we don't know what that is. Then this is gmalloc. This we don't know. Then we don't know this. Prof, we'll see. Well. All right, so let's zoom inside Go. So we have Golang, runtime, Golang, GitHub, DB, PKG. All right, that seems to be working. The one thing that is a bit of annoying is that the PCLN tab, which I was expecting to see, is not there anymore. So it might still be there, but in a different shape. So the previous argument, if you remember this version from back then, was saying, well, we have a thing called PCLN tab inside the runtime package. And that was taking most of the space. And if we look now inside the new executable here, we don't see runtime taking most of the space anymore. It's just like very negligible. And if we look into this now, we have find fug tab, which is the new probably the new implementation of PCLN tab, and hopefully using a compressed version of the code. So we're going to investigate, find func tab, how this works, and we're going to see if there are additional objects that are hidden somewhere. Let's see. So GitHub runtime. All right. So find func tab. So for this, we're going to go to okay. So the PCLN tab from before has now been replaced by a mapping from the address space into the symbol table. That is so cool. That is so cool. That means that the linker, the Go linker, has compressed the data since that was produced. That's great, actually. That is absolutely great. We have so much to explain. All right, so what else can we... So the PCLN tab from back in the days, which was this huge blob of data here, has been compressed and now it's much smaller. That is amazing. So PCLN tab doesn't exist anymore, and the thing that replaces it is actually much smaller. So how much smaller? Just 300K on these big executables that I'm working with. So we have here an executable that is 69 megabytes. And that might actually be smaller than back in the days, actually. That is so cool. That is so cool. All right, so that is completely worth talking about. So let's talk about the explanation here. So executed often, so ln tab, and then we have this, and then this. All right, analysis. So C++ entries. Go entries. Okay, so that actually probably has changed because we don't have RocksDB anymore. So the Go code has grown probably. So if you look, 67 megabytes for Go, and we had 62 back then, but that was like 3 years ago. So it's not too bad, in fact. Then how much dependency code do we have? So we have a lot of dependency code here. That we will need to tally or maybe subtract. So 67 minus 55, that would be 12. So we have 12 megabytes in this list of dependencies here, which is from the Go runtime, but also from the Google Golang org repository, which is things like protobuf and other things that are really dependencies. And then if we look inside here, we will see that we have a couple of dependencies of different sources, biggest of one being the AWS SDK. It's kind of strange actually, because Google CockroachDB does not really use much of AWS. But anyway, so the core of CockroachDB code is 44 megabytes out of 67. And then inside this, we will have a little bit of Pebble dependencies, a little bit of the Earth dependencies. And inside the CockroachDB code, this is the main split. Most of the space is being used by SQL. We're going to break that down in a second. Then we have the geospatial features, which is a huge amount of small functions and lookup tables and other things. So not completely unexpected. The KV package is somewhat large because it has complex code, really. So that is not fully unexpected either. So no complaints here. Then we have a separate, so this is the submodules of SQL package, the SQL package itself. Then we have RochePB, common data structures, util server, CCL, that is the license features, the workload thingy. This is actually not too large. Server package, not surprising. CLI package. All this is completely fine, actually. All this is very much expected. So Geo is large, but doesn't strike me as unacceptably so. A very huge amount dedicated to small functions, and then there is some kind of approach based. Maybe there is some space to be gained if there are some lookup data structure or something. I don't know yet. We'll see. But let's see what this big chunk of SQL is. So call exec is by far the biggest one. It's an OPT. So what is in call exec that is so large? We have those blocks here. So the cell, the hash, exec join. And if I open this, what does this tell me? This is generated code. Next method. Child count init for one single operator with some data types. Okay, so what we're seeing here is a large amount of generated code. That's what's going on. So there might be some study to be done about how to make this smaller. We don't know yet, but it's okay. Schema change. Util server. Okay, well, I think we achieved success in regenerating the data with a new format and analyzing the new structure and so on. So it's kind of cool. Let's see. Is this the right way to present this information? Right now we have a breakdown by path, but it's actually combining together a package with its sub-dependencies. I would argue this is a little bit difficult to read for something like the SQL package, because we have the SQL package itself here, and it has the SQL dependencies here. Is that all right? Do we want this? And then inside KV, we have the KV package itself, and then KV server is here, and then KV server own package is here. Actually, I'm kind of surprised. Why do I have so much? Yeah, okay. Let's not complain too much about this. So would we want to group those things together? Have SQL dot and SQL slash. So I think here I already see an improvement, and that is to group the package own size as a sub entity of the package container, so that we flip the side inside the other size. Let's try to do this. So how would we do this? There is something going on in this file here, which is simplify, I think. So what does simplify do again? Transform. Takes all the values. Oh, this is a recursive function. And then uses flatten. equals.append. Oh, it's transformed something that is containing. Okay. I start to understand. So this is really transforming a dictionary into something that has children, but where the children are simplified. All right, so let's look at this out.py that we had to start with. It's a little bit slow. Yes, there is a source highlights program. All right, so we have SQL. Oh, this makes me sad a little bit. Go.itab.blah blah blah. We actually probably want to assign the size that corresponds to that entity to its respective package. This is not achieved here, I think. It's probably much better if we were able to indent this table a little bit, because this is not exactly easy to read. So tab to pydict. So can we prettify this? Yes, we can. All right. To dict. It's much slower this time because pprint is adding indentation, so there is much more data to write. That's okay. So we have C++ code. That's the way we wanted it. So that seems to be processed properly. And what we want is to go to the, well, first to see a little bit the general structure. So here we have complicated functions. They seem to be fine again. All this is currently fine. Then we have some constants, like floating point constants. C++, archive, children.zip. Oh, these are Go packages now. Okay, maybe. Buff.io, reader, children, yeah. And now we see those things here. Okay, go.itab.reader. I see. Oh, so they are in fact under those packages. So it's not too bad actually. We don't have many top level unattributed sizes, like the itab things are in fact under, so to speak, under the package where they belong already. So that's we're clear on this. So let's go back to the previous code. Yeah, so no trouble here. All right, we're good. And then we have the simplify, and then that's where we had a little bit of a trouble here, which is that the data JSON dump. Let's see. Python JSON dump. Can we indent the output to make it easier to read dump. I want something here indent. Is none. All right. Now we have here the data structure in JSON. And we are going to search for SQL/. Name SQL dot. All right, that's what we have here. In fact, I actually still. So what again? What I would like to achieve is to bring the SQL package's own, or like a Go package's own symbols as a subtree alongside, say, its sub packages, so that the own package and the dependencies are side by side in the visualization. And that is the complexity here. Store. What is the store function about? Is it recursive? All right, so here we are. SQL dot. SQL dot. And then this SQL. Oh, it's going to be okay. Dot. We don't have children. New server. Init task. Doctor. Interesting. Okay, so we have call exec dot and call exec slash. That's the one that is annoying me. So path is this, store rec is, and then if we have this, prefix plus path plus name. Prefix, what is prefix? Oh, prefix is go. I see. Then the path is the components, and then the name is the component. All right, so we are going to do this just for the sake of understanding what's going on. All right. I said thank you. All right. So what do we have for SQL dot? Better. All right, so we have github.com, cockroachdb, cockroachpkg, SQL, and then this. And then separately, we will have SQL slash in a little bit of scrolling. Now, all this is going to be here, SQL slash. So we have SQL dot here and SQL slash here. And that's the difference between the two. So what we want here is to transform something that finishes with SQL dot by something that finishes with SQL slash, then another item here, which is going to be self. CockroachDB. Okay, well. So then we have the path. All right, so if the length, so what's the path dot, that's length in Python. How does that work again? I'm confused by Go. My gosh, I'm confused by Go. Python. Yeah, okay. If len of path is greater than 0, and path is the last element, ends with, say, dot, then we're going to substitute this. Self. Cool. Let's try this. Okay, that is better, but it's kind of annoying. Well, let's try it. Let's try it. Let's just try it. All right, let's go here. Oh, we still see SQL dot and SQL slash side by side. That's not what we wanted. Let's force refresh this. Maybe. I did do the right thing here. Yeah. Was that the right command? Yeah, it was. Why it says message file not found? I don't know why. Maybe SQL. Not still not side. And I'm not seeing my self thing here. Oh, we do see it here. Parser self. Self is here. Okay, that's actually not bad, but why do I see call exec slash here? That is so strange. That is so strange, and it's not what we wanted. It's not very far, though, but it's not what we wanted. All right. Slash. Aha. Aha. So SQL dot slash slot open slash self. Oh, that's because we have a function. We have a function name. Oh, that's why. That's why. Interesting. All right. So this is trying to be too clever. It's not the right place to be clever. It's because we don't know at this point yet what the parenting relationship will be between the packages and the functions. Like we have visual things like STK obj, stack object that are under functions that are themselves under a package. And so we can just look at the last part of a path and then add self, because there might be more items under. So what we need here is something slightly different. We probably need, when we are constructing, when we are simplifying, that's the other thing. So let's regenerate that file without the oopsie. Here, yeah. So in the simplify here, if we have both a package with a slash and a package with a dot side by side, we are going to do something else. We're going to add the slash self inside the package. All right. So that seems to be the right place. All right. So transform values. So here we have every time we have here something. We are saying C0 is, oh my gosh, we're flattening. Flattening is say concatenations of the names of all the elements under. So it becomes ename. Ename seems to be a string. C0. C. Oh, C is okay. So that's a slice of the names. So if we have at a given level, there are children at the first component, there's just one component, then the name of the entity is given by an attribute, and we get children. And what is ename otherwise? Oh, otherwise ename is empty. I see. So that's the level at which we will want. So if there are children in the dictionary and the name at that level oh, name. There is no such thing as something called a name. Oh, it's here. Oh, I see. Its name is K. I see. So this captures the name of the item. So if the name is... My gosh, this is complicated. K is ename. Is V. Oh, it constructs as a fic. Ah, I see. It's here. I see. Okay. So we are looking at this d.items. The name is K. Fast append V. Oh, that's what we want. So that's where we are going to introduce a key. I don't remember. Is directory iteration in Python safe? not Python map iteration. Changing the size of dictionary during iteration is not allowed. Alright, so that means we need to create a new directory. Alright. Mm-hmm. Oops. Oh, maybe copy self is okay. So that is transform SQL.x into SQL.shelf.x. If that also exists. I think that is the case. We will We'll see if that is true. Oh, clone. Clone. How do you make a copy? Python copy dict. I know the slow way, but copy, dot copy. Oh, okay. Let's try it. Let's just try it. Better. I don't see the SQL thing anymore. Here, if I click here, I will see it hopefully with self. Here. Yes, it is here. Self. These are all the methods and variables inside the SQL package, and we see like planner is a big chunk, glob, I don't know what glob is actually a big chunk too. As are probably global nameless functions, like closures of different kinds. And then we have a couple of other functions. So okay, so we transposed, so it makes it much easier to understand. So parser will have probably, so it doesn't have any sub packages. Catalog probably have something. It will have self as well. Yeah, that's good. So we are going to rename self to use special symbols, like we did with the other thing. Self. Dot. Cool. And we are going to remove the indentation because this makes the JavaScript much slower to load. And we need to restart the server. Cool, okay, so that seems to work. Now let's see how the JavaScript seems to work. Remap, then display. Position. Next. display JSON. Yeah, well, I will probably need to study this a little bit more in time. All right, so this is better. So runtime, prof. All right, so we navigated all this, and we have quite a few things to look at. So KV server is the largest one. Cool. All right, well, I would say, coming back to the article that we started with, the proportion of things has changed quite a lot, and we will look into that table after a little while. And the C++ code has changed quite a lot as well. So let's see what the C++ code has to offer us. Like it's just 1.8 megabyte now, where it was like multiple megabytes before. How much did we have? Like if we start from the beginning. Yeah, okay, so we had actually negligible C++ here. We have 8.4 megabytes in the original version. And now we have reduced this to just like 1.8 megabyte. And it's because RocksDB is not there anymore. We have instead something called zstd. We don't know exactly what it is, but it seems to be something related to compression. And it's not even much, just 640k. Profiling some stuff, some Huffman compression code. Why do you have both Huffman and zstd? I don't know. And then a lot of small change. So it's not super interesting. And then inside Go, we have plenty of non-GitHub dependencies here to extent of 12 megabytes. Including some dependencies that doesn't seem to be used. The largest of which being Golang X text, which needs to be upgraded because it has some bugs. Then Golang org protobufs. This is not unexpected since we're using protobuf heavily. Runtime 1.2 megabyte. And then the rest is CockroachDB code. So that's like what it is. And so the analysis is actually pretty different. So this entire discussion of PCLN tab and other things here needs to be replaced by a new analysis entirely. So that's really what I should be doing from now on. So this is not super exciting, probably. I mean, like it is exciting probably when after it's written to read it for people who are interested in this topic. But the process of writing it is not going to be very exciting. So I'm going to say, let's not spend too much time on this topic today. And since it's already been more than 1 hour and a quarter, I think we're going to stop it here for today. I will do the writing on this analysis off camera, and then I will publish the updated link probably on Twitter. So if you're watching along, you can go to Twitter feed and look into it. And there will probably be a forward link from this version from 2018 to the new version. So here we are. Thank you for accompanying this project today, this redo of the analysis. And thank you for watching. Thank you for being around. And let's talk again next week. See you.